Okay guys, Unit 4 review. This is going to be, I double stacked this so I can reinforce concepts. The assessment is not this long. Okay. It says write an equation for the table. You see the temperature in Celsius, 0, 5, 10, 15, and the velocity meters per second, V. So to write an equation, you're going to draw a line, and it's going to say equals V up at the top. So V starts at 331. Plus, but instead of times x, it's going to be times the c variable. Because it's like an xy table, equals v, and then the c is the rate of change. Now to find out what your rate of change is, you start at the bottom, okay, and you subtract. 340 minus 337, I got 3, okay. 337 minus 334 is 3. It needs to be just like I'm doing it, and then 3. So, 3 is the rate of change, but you see this isn't going 0, 1, 2, 3, 4. 50 minus 10 is 5, 5, and 5. So you have to divide your 3 by your 5. Okay? So you have 331 plus, so 3 divided by 5 is 0.6. Remember, if it's a really funky looking decimal, second PRB it, times by C equals V. Now if you want to check your answer, you go 331 plus 0.6 times, and we'll go with 10, and it should be equal to 337, which it is, okay? 331 plus 0.6 times 15 should be equal to 340, so I've done that. The equation works. So you start at the bottom and just figure out the difference, the common difference, okay? Should be the same difference every time. But we had to divide the 3 by 5 because this was going by 5s and not 1s. If it's going by 1s, you really don't need to divide. You can if you want. Okay, tell her the function is linear or nonlinear. Your y's have to give you the same difference every time, and the x's have to be the same difference every time too. So, 7 minus 3 is 4. 3 minus negative 1. That's the same as 3 plus 1, because plus plus, that's 4. Negative 1 minus negative 5, you're subtracting, okay? That's the same as negative 1 plus 5, it'd be negative 1, 5 to the right on a number line, that's 4 as well, okay? Now we come over here, 3 minus 1 is 2. 1 minus negative 1 is 2. And negative 1 minus negative 3 is 2. So both columns have the same common difference every time, so that is linear. It's got to be the same difference every time. So 10 minus 5 is 5, but 5 minus 2 is 3. Okay? So we know right away that's nonlinear. I mean, this goes by 1s, but it's the y that needs to. Okay, now everybody's favorite problems. You're buying streamers that cost $2.47 for each party. I'm going to do us all a favor and change the $24. Let's just go $15. Okay, that's me changing it. You have $15 to spend. What's a reasonable domain range for this situation? Is a function continuous or discrete? So, what I need to do is domain, range. We want to put those in brackets, okay? Then continuous or discrete. Now, of course, to develop a domain and range, we want to make our input-output table. So, X, Y. So my two units are money and streamers, okay? Streamers and money. Have what you're buying. Money is the Y. What you're buying is the X. Now, you got to identify what your limit is. My limit's $15, so that's $15. $15. So limit on the money side is 15. So now we start our table. So on this side, as soon as I get past 15, I'm done. So 0, if you don't buy any streamers, you don't pay any money. If you buy one streamer, you add 247. If you buy a second streamer, you'd add another 247. That's 494. Third streamer, you add another 2.47 to that. 741. Okay. Fourth streamer. Remember, we just have to get to 15 here. I kind of cut this down. 988. Fifth streamer. Remember, you know you're done when you cross the 15 limit on the money side. 12.35. 1482, and I don't think I can get to 7. Okay, so we're done. So the domain is from 0 to 6. Domain's all the possible values for x, 0 to 6. So I put 0, 6. The range 0 to $14.82. Again, x, y. If on a money problem, x is the thing you're buying, and then money's going to be the y. Okay, continuous or discrete. Well, I can't go to a store and buy 1.5 streamers, so that's discrete. So if I graphed all these points, I would not connect them. Okay, number 5. Graph the equation y equals negative 4x plus 3. So I make just a simple input-output table, 0, 1, 2. So I go negative 4 times x plus 3. Negative 4 times x plus 3, and negative 4 times x plus 3. So 0. Negative 4 times 0 is 0. 0 plus 3 is 3. So 0, 3. And I'm not going to make you find a fourth point on your line, okay? That was just for time, for understanding purposes. Negative 4 times 1 is negative 4. Negative 4 plus 3 is negative 1. So the input's 1, the output's negative 1. Then I substitute 2 in for x. Negative 4 times 2 is negative 8. Negative 8 plus 3 is negative 5. So the input's 2, the output's negative 5. So this is the x, this is the y. If you want to number your graph, do it. If not, I don't care. If you know where the point goes, just put them. I'm going to number mine just because I'm the teacher, but you do not have to number them if you number the axis if you know where it goes. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 0, 3. 0 on x is the middle, 3 is right here. Okay. 1, negative 1, right 1, down 1, to 1, negative 1, then to 2 and negative 5. Okay, and that's the line. And that line then shows a bunch of other input-output points. You don't have to find the other one. I do need to get a ruler for my graph, though. Okay, so I set that on there. There we are. Okay, I don't need that other point today. If it doesn't say it in the directions, just you don't have to. Arrows on both ends, please. Okay. Okay, total of the graph represents a function. You are doing the vertical line test. If it's a bunch of discrete points not connected, you just simply, I went through one. Then as soon as I go through more than one, I know it's a non-function. Because remember, this is the x-axis. That's repeated x's. You can't do that. So non-function. Vertical line, not a horizontal line. Okay, next one. Now we have a continuous graph. All this is filled with points. Okay. Tell whether it's a function. Well, when it's continuous, it's easy. You just draw a big line through there, and that crosses the graph once, twice. So that is a non-function. Crosses it once, it's a function. Now we're back to discrete points. So 1, 1, 1, 1, 1, 1, 1. That is a function. Now we're identifying a function. These are, think of a graph. These are points on the graph. Okay, you don't see the graph. Identify the domain and range. Total the relations as a function. Remember, domain is the possible x values. So domain range. So domain, you have, and these are discrete points, not negative 2, 8, 3, 5, and then 5, 6, 12, 6. Now circle the domain. You don't really care if about the range. Do you have repeats in the domain, or are they all different numbers? Negative 2, 8, 3, 5. Okay, they're all different. So we have a function. I don't care if the range repeats. So function's all about the domain. Okay, x, y, x, y, x, y, x, y. Domain, range. So 9, 3, 4, 9. 6, 8, 9.5, and 2. Okay, I have repeats of 9 in the domain. Okay, so that is a non-function. Okay, now this one, a bottle holds 48 teaspoons of vanilla. The amount A of vanilla remaining in the bottle decreases by 2 tablespoons for batch B of cookies. Write a function rule for the situation. It's the same as you're doing on the first problem. Okay, equals A is your dependent variable. It's the first one you have. Okay, so A starts at 48. Then you're decreasing, so you need to make your 2 a negative times the number of batches B. So the equation is 48. Then we're going down by 2 every time there's a batch, so times B equals A. Okay. Negative 2 is known as your slope in physical science. Okay, that's what it changes by. Okay, this one's easy. This is called function notation. F of x equals negative 2x plus 4. F of 5 means you simply need to just put 5 into the function for x and evaluate. So negative 2 times 5 plus 4. So you multiply first, negative 10. Then you take negative 10 plus 4 and it's negative 6. So write the answer right there. F of 5 equals negative 6. Okay, now I'm going to run through these again. Okay. Write a function for the table. It's the same as write an equation. So equals, by the way, I put that needs to be G. Sorry about that. So G, we start at 11.2. Then the change is dependent upon the M. Okay, so times M. So we go to our G. What's the difference every time? We'll go 8.2 minus 9.2, negative 1. And I'm going to explain why I start at the bottom after I negative 1. Want to guess what 10.2 minus 11.2 is? Negative 1. Now the reason you go bottom, because that finds a difference. If I start on top, I can see I'm going down 1, down 1, down 1, hence the negative. But I look over here and I see, oh shoot, we're not going by 1s there. So that needs to be divided by what this goes by. So 51 minus 34, 17. 17 and 17. So as you can see, from 0 to 17, 17, 17. So we're going to divide that. So my equation is 11.2 plus, you can divide negative 1 by 17. I don't want that. Go back to your second PRB and you get negative 1/17. Times M equals G. If you want to test the answer, pick an input, let's say 34, 11.2 plus negative 1/17 times 34, click equals, you should get an output of 9.2. We did, okay. Okay, linear or non-linear, okay. Well, 14, there's got to be the same difference every time. 3, 3, and 3 minus 1, 1, 1, that is linear. That's a difference of 60 when you minus, and that's 6. So right away I know that's non-linear. Got to be the same difference every time on the y side. Okay, domain range. The story problem. I want to buy limited edition coins for $22 each. There's a limit of 8 coins for a customer. Find the domain and range of the relationship. Is a function continuous or discrete? So domain and range. And then continuous or discrete. Okay, let's get an XY input-output table going. You got coins and dollars. Remember, dollars should never be X. Dollars is always the dependent unit. What I'm buying is X, because it's not a time problem. Time, we know time's always X, but in a money problem, the thing I'm buying is the Y. Okay, limit of 8, but that's 8 coins, so the limit is over here. So I stop when this column's at 8. 0 coins, $0. Don't put the 22. The 22 is when you start buying the coins. So plus 22, that's 22. Plus 22, 44. Plus 22, 66. Plus 22, 88. Plus 22, it's going to give you 110. Okay. Plus 20, remember you're stopping at 8 here. Plus 22, that's going to be 132. Plus 22, it's going to be 154. Plus 22, 176. Stop. We have our domain 0, 8. The range 0 to 176. Okay. Now you can't buy 1.5 coins. That is discrete. An example of continuous would be like if X was hours. Okay, you can do 1.5 hours, or like gallons. Okay, graph the equation. Y equals 2 times X minus 4. So X, Y. 0, 1, 2. So 2 times X minus 4, 2 times X minus 4, 2 times X minus 4. 2 times 0 is 0. 0 minus 4 is negative 4. So the input 0, the output negative 4. I'm not going to number this time. You can if you want, but 2 times 1 is 2. 2 minus 4 is negative 2. So 1, negative 2. 2 times 2 is 4. 4 minus 4 is 0. So 2, 0. Okay, so X, 0 is right here. Negative 4 on Y. 1, 2, 3, 4. X1, positive 1's here. Negative 2 on Y is down 2. 2, 0. So 2 zeros right there. Okay. And of course that is continuous because we can put decimals in for X. We just don't do it because... And of course it goes on in both directions. Okay, you can put negatives in for X, positives, everything. Okay, is this a function? Well, 1, 1, 1, 1, 1, 1, 1, 1, 1, function. Is it a function? 1, 1, 1, 1. Okay, more than 1, that's a non-function. You have X repeated 3 times. Okay, continuous graph. Looks like I crossed it twice. So that's a non-function. If you cross a continuous graph once, it's a function. Okay, then I see a bunch of discrete points, so I got to determine whether it's a function or not. So domain, tell whether the relation's a function. So domain, range. Negative 2, 0, 4, 5. That's your X's. 0.5, 2.5, 6.5, 2.5. Now remember, this is all about the domain. It doesn't matter if the range repeats. It's the domain. I don't have any repeats. That is a function. Okay, domain, range. 6, 4, 6, 5. By the way, we know it's not a function because of the repeated 6. 5, 3, 4, and 8. Okay. Looks like I have repeats of 6, so that is a non-function. Okay, the volume V remaining at 243 cubic foot pile of gravel decreases by 0.2 cubic feet with each shovel, S of gravel spread in a walkway. Write a function rule to represent the situation. So the dependent variable is V, 243. Okay, now the independent variable is S, and you're decreasing, so when you express it, it has to be by a negative. Okay. So 243 plus negative 0.2 times S equals V. Okay, then finally, f of x equals negative 2x plus 5. What's f of negative 4? Well, you just substitute negative 4 for x. And then don't stop there. You need to figure out what the answer is. Got to figure out what the output is. Well, that's 8. 8 plus 5 is 13.